Raycast. What are these weird arrow things? How can we use them? And why are they useful for game development? Alright, well, Raycast, when we create this object or add this into our scene, it looks like it's just this little arrow. And we can modify its length, for example, which will be its cast to direction on the inspector. So if we were to change it to, say, 80, that arrow is going to get much longer, and we're going positive, so it's pointing down, but if we were to go negative, it's going to point up. So you can kind of decide what direction it's pointing in and how far it's going. But what is this thing? Well, a raycast, simply put, is a node, at least here in Godot, and it's used to simulate the behavior of a ray in a game world. Okay, of course, that makes sense, but what exactly does this ray do? Well, a ray is a straight line that starts at a specific point, as we went over right here at the beginning, and extends in a particular direction, as you saw there, me going up and down, and it goes for a set length, or where it's casting to. Raycasts are useful in game development because they can be useful for detecting collisions with objects within a game world, but they do this in a little more accurate way, I guess you could say. Now, some examples of these I would say definitely help you understand these a little more. So what I've got here is just a small little platformer, and my little enemy here, this walker that I've called it, has a raycast, but it's not inside of it, it's not protruding out of it, it's actually beside it and pointing down. That seems a little weird. Why is that? Well, in this case, we're actually using this raycast to point down to see if we're colliding with the ground to simulate this Super Mario enemy behavior. So if I were to go into the level, we can see all of my little guys here have a raycast pointing down. And if we go ahead and run this, we see there they go. And when they get close to the edge, where the arrow stops detecting the ground, it's actually coded to turn around at that point. So if we were to come in and get an idea of what's going on here, our little enemy, our walker, drops down to the ground. He starts walking. Our arrow is connecting with the ground here, right on the tip. And it's walking, he's walking, and we no longer detect the ground. So now he's going to turn around and walk in the other direction. And it's going to continue to do that indefinitely. Remember, when this sprite flips, the raycast is going to be flipped onto the other side because we're flipping the whole thing, and the raycast is a child of this character. And then, of course, in this particular example, they're also coded to flip around when they bump into each other as well, when that happens. But that's essentially what's going on here with the raycast here. And if we were to go in, say maybe increase this to 50, as an example, and we can go back and watch these guys go. We can see that arrow is a lot further down. He's not going to turn around until he's a lot closer to the edge. And we can go ahead and you can see that with a quick play. There you go. He's getting a lot closer to the edge there with that. And what if we just went something crazy? What if we had something like that 80? If we had something like that 80 in there, and we'll give that a try. But we see he's going pretty well all the way up to the edge, and then he's turning around in this case. At least the edge for that arrow. And that's the insane thing that we can go with here, right? So if we were to have, say, something absolutely insane, right? Say we had this arrow casting 2,000 on its distance. Well, if we're looking at that, it's going to go down, it's going to go, and in this case, it's not going to find anything at this exact edge. but this enemy might continue walking to the left. He'll completely fall off the edge because he's still going to be detecting that ground down below. So if we take a look. So again, as we go back and take a look at that, we see his arrow extends way below. And when he actually gets to the edge of this, where he no longer detects this ground, he's not detecting any other ground below him. So he's going to do his job. He'll turn around and walk the other way. Whereas this guy, when his arrow does reach the edge, he's still detecting new ground below him. So he's still going to keep walking. So that's why they change direction on the right. And then change direction on the right. And then on the left, they just continuously walk. Because they detect off the edge here. They detect off the edge here. And then they fall off on the bottom. Which we can't see that low, but we see that with the arrow. So you can see how Raycasts can be useful in something like a platformer example here. I'm just going to go ahead and fix this back. And that's one way that a Raycast can be used to help with an enemy's behavior. Another example of this would be if you've played any first-person game where you can interact with an object, for example. Now, that Raycast, obviously that's going to be in 3D, so it's not here, but same premise applies. It goes 1 point, extends out in a direction to a certain distance, right? It has a cast to a certain location. And I should note that these are usually disabled by default for some reason. I don't know if that's changed in 4.0. I highly doubt that. This is a 3.x project I have open. But in 3D, the only difference is instead of casting out, say, from an enemy like this, or a Super Mario type of AI behavior, in 3D, it's going to cast, usually going from the center of your camera, and it's going to go out to a set distance. And that's why you can only interact with objects in games up to a certain distance away, and then your prompt disappears, right? So when you look at an object to get close enough, you usually have a use or interact button pop up on the screen, which means that the object that can be interacted with is now being collided with by that object, right? Being connected by that Raycast. And saying, hey, we can interact with this. That's triggering the display of our use prompt on the screen. Fantastic. Alright. And then, of course, you can interact with that. That sends out whatever signals or things that you want to do in that specific game that causes its triggers. But the main thing is that Raycast goes from the camera, extends out, and when it collides with an object you can interact it with, that is within that range, you're able to interact with it. And that's why if you look away, it disappears. And why if you have other objects kind of in front, it can kind of be a little annoying in some games, because I guess maybe their detection box is a little too big and it becomes a little odd in that case. But that's an example of a Raycast in 3D. Again, a good example of this would be thinking about Skyrim. Alright, so if we come here to this page here, now I just picked a random video here on YouTube. This one is called Can You Steal Every Item in Riften? The channel is That's Cool Dude. And we have a nice little example here of a Raycast work. So the Raycast is going to be coming from usually the center of the screen, so from the crosshair and pointing out and out away from the camera in whatever that cast to distance is going to be. And as we see him walk around, we can see different detections. So there we go. We got the tankard, baskets, and we can see it's constantly updating the prompt that is on the screen in this case, because we're printing out probably the name of the object that we're colliding with. But we can see how this constantly changing. And as soon as the object is no longer colliding with something that can be interacted with, that display completely disappears. So obviously I'm not going to play all of their video, but We got a small example there with how that can be used in a 3D game, especially if you want to make a first-person game. Another useful thing with Raycast here when it comes to 3D is, like you can see in this Unity video here by MK's Games from 2 years ago. And that's just this video right here that's going over. We can see right there in their thumbnail and get an idea off of their title that they're using a raycast in order to determine enemy detection for enemy visions, right? Instead of using an area to detect, they're using a raycast that they can maybe attach to the enemy's head, and then the enemy can only see what's directly in front of them in that case. I don't know if that's exactly what they're doing in this one, but you can see you could use a raycast for a vision cone. As so they can be used for a line of sight testing, which of course can be very important for AI controlled characters to need to make decisions based on whether or not they can see the player or what they're seeing in the game world. So by raycasting in a direction of another object, the AI character can determine whether that object is visible or not and make the appropriate decisions. So all that starts going into creating video game AI, of course. If you like hit scan weapons, then you can just detect an object and you can do it that way. And that would also give your weapon a distance that it can shoot. But overall, raycasts can be a very important node in Godot and very useful throughout game development, whether you work 2D or 3D, especially when it comes to creating AI, and offers that more precise collision detection in line of sight testing that can be very critical for a lot of video game genres out there. And these raycasts, they allow game developers to create a more immersive and interactive game world and experience for all of us to enjoy, or if you're the developer, for other people to enjoy. Alright, hopefully that kind of explains raycast there, and I'll just show you a piece of code if you're wondering about how it works here. Let's go ahead and find section. There we go. So we can just call the isColliding function here that I have on line 43. So you can just get your raycast object and check isColliding. And in this case, if it's false, which means the ground is no longer underneath of my enemy here, character, the walker, then I'm completely changing the direction that I'm going in. But that's all you would have to do, is you can just call it the isColliding function. And of course, if you're in C#, it's just capital I, S, no underscore, capital C. Like you see there. It should just be like that for C#. So, not too different, but there you go. There's essentially what raycasts are, some examples of how we use them in video game development, and how we can check whether or not they are colliding with an object or not. Alright, so before I ramble on anymore, that's it. Take care, have yourselves a good one, and I'll see you guys in the next one.